हर जगह जो है म्यूपी का इस्तेमाल हो रहा है. So what we had said कि MUP is basically a programmable device जिसके अंदर आप उसकी आप एज अ प्रोग्रामर आपके पास कुछ फंक्शंस है, कुछ एबिलिटीज है, आप उसको प्रोग्राम कर सकते हो. उसमें मेमोरी है, इनपुट आउटपुट, एंड उसके अंदर भी आप एज वी सेड कि आपके पास फ्लिप फ्लॉप्स वगैरह वैसे कई कई कंपोनेंट्स है. सो 4 कंपोनेंट्स की बात की थी. दैट MUP मेमोरी है, आउटपुट है. तो बेसिकली उसी चीज को हमने तब डिस्कस किया था. फिर वी सेड दैट MUP जो है, हम एंड में कोई भी न्यूमोनिक लिखते हैं, चाहे वो हेक्स में लिखे या चाहे न्यूमोनिक्स में लिखे, बट इन द एंड MUP ओनली अंडरस्टैंड्स बाइनरी. उसका जो मेन प्रोसेसर है वो सिर्फ बाइनरी समझता है. तो उसके लिए बाइनरी डिजिट्स है इम्पोर्टेंट. फिर मेमोरी है भाई, आप जो बोलोगे, whatever instruction you give and whatever output is there, and in between उसके लिए उसको it requires a memory. Input output हुआ. Then we said my MUP as a CPU. CPU के अंदर जो है what is important is your ALU, that is your arithmetic logic unit, which carries out all the functions. फिर साथ ही साथ आपने we said कि भाई decoders, counters, control units भी चाहिए उसको. तो दैट में MUP का जो सारा काम है वो माइक्रो प्रोसेसर में हो रहा है. एंड साथ में वी सेड कि भाई कंट्रोल यूनिट्स है, बस है. वी हैड डिस्कस्ड ऑल दोस थिंग्स कि ये बेसिक डायग्राम ऑफ ये है, कंप्यूटर है, जो कि MUP से अगर किया जाए तो ये जो यूनिट है आपकी ALU वाली, दैट गेट्स रिप्लेस्ड विद अ MUP. And microcontroller is obviously it is little more self-contained compared to a microprocessor. तो वो थोड़ा सा और एडवांस्ड हो जाता है, जो हम होपफुली देखेंगे उसको. we'll see in our work later. And then we said about the microprocessors, भाई उसका अलग अलग चीजें हो रही है, उसका ऑर्गेनाइजेशन है. तो उसके अंदर as we said कि भाई ALU है, रजिस्टर है, कंट्रोल है, and then somebody asking something. Oh, is somebody saying something or?
Someone is recording.
Yeah. Okay. We need to record it also.
Someone is recording.
Okay, so somebody is recording, or it's okay. Stop recording. It seems stop recording. No problem. Who is recording, or is it recording from my side, or I have no problem. Let me also. Let's do one thing. That I should have recorded it. Anyway, then somebody is recording. Then let's do one thing that. I will start with the recording. Stop this recording. I will start and then we'll have it. Okay? That way we'll do it. I will start here. Okay. So let's continue. We were discussing about as those basics of MUP, what we said. भाई MUP के अंदर what are the, we go try to go deeper and deeper. So a very rudimentary presentation, ALU registers. Somebody trying to say something. Recording to हो रहा है ना. Let's move ahead. This is all we had. Last time we had recorded, we had discussed about it. Then we said कि भाई microcomputer है, so it is performing the functions of MUP is performing the functions of microprocessor, CPU. So it's a complete computer similar to any other computer, except कि CPU का जो function है, that MUP is doing it. And then there are similar peripherals which are used. Mnemonics was there, as we said, कि भाई mnemonic is required, as it is difficult for common people or for end users. For that we have the purpose of mnemonics. So then there's the segments, that integration is done, means manufacturing is done using LSI, VLSI, and various functions are performed. And the segments, we said ALU is one of them, performing all the logical units and or exclusive or etc. The register arrays are there, and register arrays contain your registers, 8-bit registers, and it can be combined also to form your 16-bit in case required. And we said कि register A भी है इसके अंदर, in which all the functions are actually carried out always in A, and rest all are others are used for storage purpose. And then there's a control unit which includes all those buses for the flow of data to and fro, and as well as for addressing. Then we said there's some relationship and all. We tried to give an analogy between the two, between the full adder and all. So that's good for analogy. We'll move ahead about that. Then there's the memory pattern here. So memory pattern के अंदर भाई need to store data, selects, so bit pattern is required. Okay. See, bit pattern requires initiate microprogram operations. Programmer selects appropriate bit patterns and enters it. Okay, it's like inputting. Anyway, all these things are part of the system. So memory is also anyway a part of it. And again, data, either this can be data or this can be part of your actual, what we say, operational code also, and whatever, that way. Then there's the ROM and read-write memories. So ROM, you cannot alter it. It has the sound that is which is stored within the MUP's memory, and it will also provide the equivalent binary digits. You will put the mnemonic, आप mnemonic अंदर डालोगे, internally system जो है उसका binary code processor को देगा, तभी फिर वो correctly function करेगा. And we'll see about it today कि कैसे एक simple program को execute किया जा सकता है. फिर हम instruction sets भी देखेंगे आज. फिर we said कि भाई read write memory है, जैसे user memory हम बात की थी. It is used to store programs, data, hex keys, and all were various ways in which you can do it. फिर इनपुट आउटपुट की बातें की तो अगेन पेरिफेरल्स आ गए. तो कीबोर्ड, स्विचेस, A to D कन्वर्टर्स, D to A कन्वर्टर आएगा रिवर्स में जब जाओगे तो. LEDs है, कैथोड रे, CRT, D to A, all ways in which today's modern system provides you the ability to display or to take information and to display information. Summary हमने बात की थी भाई, read instructions etc. memory की बात की थी. So I am not going into all those details since we've already spoken about them in the last time. Input devices जो हम बात की है, like used for entering data and instructions, and it output के अंदर obviously you display your data or give it to some other source, other device, and the output becomes the source that way. Then the bus is there. So hexadecimal system की हम बात की थी, as you people are familiar that a hex के अंदर भाई 0 से क्या कहते हैं आपका decimal is 0 to 9, but this is from 0 to 9 plus from 10 to 15 becomes your A to H, A to F, sorry, and then you people know that how to use it. You people are accustomed to that. So it is useful as far as representation of data is concerned. Then assembly language program की बात की तो इसके अंदर क्या है that what we said that again we said कि mnemonics की बातें आ गई थी, how it's important for end users to have mnemonics. Anyway, I'm sorry for it, but we'll see about it. So then we had given some examples of INRA, add B. Those were two instructions which could be used, like for the representation of what do we say? INRA is a mnemonic, add B is a mnemonic, and that gets stored in the hex in 80H. But finally, the what do we say? Or MUP is going to read this thing only, this binary digits. So the system will convert it. And similarly, by add KLF, we had given an example. And then we'll be discussing about these instructions now also further. Then we said about the writing of instructions in mnemonics. You write the instructions, hex, machine code, you find it out, load it, and you execute it. So we'll go, this is a very, very rudimentary way of saying it, but certainly we need to look at it, and which we are looking at in just now. Then we said about the 8085 hardware. ये आपका hardware model है, on the left, A is your hardware. This is a kind of software representation of it. So you had the accumulators and registers with the ALU flags. And then you had all this, the hardware model was shown, as we said, if ALU hai, registers hai, 16-bit registers and buses were there. And all those related matter was there, which we discussed. Then some software models were used, which maybe if time permits, we'll also go into it deeper also. But this is just a brief overview which we are having, that along with, and we had said that along with 8-bit, there are the 16-bit registers also, the stack pointer and the program counter. Somebody wants to say something? Okay. And go back. Somebody saying something? Are you people with me? Hello, are you people with me?
Yes, sir.
Okay. So let's continue. Let's continue. So here we said about what do we say? We were kind of recapping what we said last time, what we had discussed. Along with the 8-bit, you have the 16-bit registers, and then there's a different purpose for each, like you've got B, C, D, E, H, L, and then you can also have a combination of all these things to perform 16-bit operations. Then, as we said, accumulator is the one in which all the important mathematical or logical operations are performed. And generally in any, as we had said, that in any operation involving two registers, accumulator has to be one of them, say addition, multiplication, or whatever. That we'll see about those things. Then we had said about the flags. a number of these flags which are there, and then we set the zero flag. If it is if the result is zero, the zero flag gets set. If there's a carry, then the sign flag. So if in the, what do we say, if in your what do you call this, this flag register with its bits are there. So what we are saying is that if the sign flag is then set, if the result is 1, then the sign flag gets set, and if there's even number, then there's parity, and accordingly then we've got different functions like D0 to D, like 0 to D7 are the layout of that particular register, depending on which of the what do we say, which of those D0 to D7 becomes 1 or 0, accordingly that flag gets affected. So then we had the program counters and the stack counter. We'll see about those things later also. So it's used to sequence the execution of the instruction. Program counter is incremented by 1 in the next memory location. Stack pointer is also a register, and it points to the next subsequent what do we say, position from which the data is to be fetched. And then from here I think we stopped over there last time. So now from here we should be beginning in a fresh way and look at what does the 8085 instruction set discuss about. So there are 5 categories. One is your data transfer or copy operations, arithmetic, logical, those branching ones, and machine control ones. So as the name suggests, for data transfer is like you transfer from register A to B or something from one memory location to another without modifying the contents of the source. So examples are, say, between the registers, you're going, say, from register B to register D, or say even loading. Over here, loading is also one of them. Probably I think MBI or something, that function will be used because it's kind of an input to the system that you are giving. So loading is one of them. One is transferring, other is loading. Then within the memory location, say from some memory location to register B, or say from memory location to register A, and directly say from the input device to the accumulator. So those are kind of the what do we say, the data operations or the copy operation. Another one could be your arithmetic operation. So in arithmetic, you've got your addition and subtraction, as well as other, say, increment is there, decrement is there. So for addition, so now accumulator is, what do we say, has only 8 bits of memory. So simultaneously you can only carry out normally, what do we say, 8 bits of data. So any 8-bit data or contents of the memory can be added to the content of accumulator. Some is stored in accumulator. So no two other 8-bit registers can be added directly. And here, say like if addition is being done and there's a larger number, then in that case, say the carry flag would be set to 1, and it could be the case, or a number is small, then carry would not be set to 1. It is possible both ways. So, but DAD is a special exception where you can add 16-bit data directly in register pairs. But this is one exception, and we'll see about it, how to use it. And then in subtraction is like 8-bit data of one register is to be subtracted from the accumulator. Results are again stored in accumulator, and you're accustomed with 2's complement, and if it's negative and it's expressed in 2's complement. So again, as we said, that one of the registers has to be the accumulator, otherwise it cannot be done. Then you've got your logical operations, which includes your logic gates, as we said, all those AND or XOR can be logically ANDed or exclusive OR with the contents. Again, over here also, accumulator is important. So any 8-bit number, but one of them has to be accumulator. So that is why the speed of operation in 8085 will be a bit slower. Like if you would have had 10 operations also, then you would have to go serially only. Like in a computer, you would have had some parallel operations, it would have been much faster. But this is like a, more of a basic kind of MUP. Obviously, our current ones which we are having in our laptops are extremely advanced, but those understanding that architectures would be very difficult without studying all this basic material. So, as we said, one thing always of so in any operation, accumulator involved. Over here, rotation also in the accumulator, comparison also with the accumulator, complement also, data must be in the accumulator. So now let's look at the instruction sets. So an instruction is a command to the MUP to perform a task. अभी तक समझ आ रहा है कि थोड़ा सा मैं हिंदी में बोलना भूल गया था बातें करने में? किसी को कुछ डाउट है? पीछे जाना है वापस? डाउट? हेलो?
नो सर.
नो सर, अंडरस्टूड.
ओके, चलो ठीक है, प्रोसीड करते हैं. चलो ठीक है, तो इंस्ट्रक्शन क्या है भाई? कोई भी इंस्ट्रक्शन देना या उसको बात करनी है तो उसको इंस्ट्रक्शन कहेंगे. सो इंस्ट्रक्शन इज अ कमांड टू द म्यूपी टू परफॉर्म अ टास्क ऑन स्पेसिफाइड डेटा. तो इंस्ट्रक्शन के अंदर 2 पार्ट्स है, 2 हिस्से. वन इज द टास्क टू बी परफॉर्म, दैट्स द ऑपरेशन कोड और ऑप कोड, एंड सेकेंड इज द डेटा टू बी ऑपरेटेड ऑन. तो जो कोड है, जो एक्चुअल कोड है, उसको हम ऑप कोड कहते हैं, और जो न्यूमोनिक जो हम कहते हैं, इट्स द ऑप कोड. एंड जिसके ऊपर परफॉर्म करना है डेटा है, दैट इज कॉल्ड योर ऑपरेंड. सो लाइक MVI-B, MVI is the opcode and B is your operand. जो दूसरा जो है, या फिर किसी एक्यूमुलेटर में कुछ आप डेटा लोड कर रहे हो, तो इंस्ट्रक्शन विच गिव्स फॉर द लोडिंग इज द ऑपकोड एंड दैट डेटा विल बिकम द ऑपरेंड. What that will examples also we'll see. So the operand can also be specified in various ways. It could be 8-bit, तो 8-bit का हो सकता है, या 16 बिट्स का भी हो सकता है डेटा. इंटरनल रजिस्टर भी है, मेमोरी लोकेशन, और डायरेक्टली 16-bit addresses. So and as we are saying that 1 byte instructions के अंदर, as the name suggests, एक ही बाइट का है वो. So operand is implicit. ऑलरेडी तब पता ही है जैसे as we were saying for things like increment, तो इंक्रीमेंट के अंदर भाई जो मैटर एक्यूमुलेटर में ही है, तो ऑपरेंड इज इम्प्लिसिट, ऑलरेडी पता है कि भाई एक्यूमुलेटर में ही है, दैट इज व्हाई वी आर सेइंग इट इज इम्प्लिसिट. सो नाउ वी विल सी कि भाई अगर 1 बाइट 2 बाइट 3 बाइट का है तो उसका व्हाट काइंड ऑफ इंस्ट्रक्शंस एंड वी कैन यूज, हाउ वी कैन यूज दैम. सो लेट्स सी 1 बाइट. तो 1 बाइट के अंदर क्या है, एज वी आर सेइंग 1 byte instructions. This includes your opcode and operand in the same byte. अभी 8 बिट का आपका बाइट हो रहा है, ठीक है, 8 बिट का बाइट है. तो अगर आप यूज कर रहे हो MOV CA, contents of accumulator, copy contents of accumulator in register C. So move A to C. A is the source, C is your destination. इसका ऑलरेडी हमको लाइक ये ऑलरेडी डिफाइंड है, इट्स नॉट यूजर डिफाइंड. ये ऑलरेडी आपके पास यूजर मैन्युअल और इंस्ट्रक्शन मैन्युअल में दिस थिंग इज गिवन टू यू एंड वी नीड टू लुक अप फॉर दैट. बट ऑब्वियसली वी वोंट बी अप्लाइंग दिस थिंग. हम या तो ये एंटर करेंगे या ये न्यूमोनिक है, ये हेक्स कोड है. नाउ सी add B. So add, obviously add contents of register B to contents of accumulator. So it's not add BA, right? Opcode is add, यहाँ पे B is your operand. ए को स्पेसिफाई करने की जरूरत नहीं है. तो दैट्स हाउ यू गेट योर, ये आपका ये इसका 80H. देन विल आल्सो हैव अ लुक कि भाई म्यूपी जो है, हाउ डज इट डिफरेंशिएट बिटवीन एन इंस्ट्रक्शन एंड आल्सो डेटा. दैट आल्सो विल कम लेटर स्टेज. तो CMA complement करना है, as I said. तो ऑपरेंड इज इम्प्लिसिट, बोलने की जरूरत ही नहीं, क्योंकि सारा काम जो है एक्यूमुलेटर में ही होने वाला है. That's why it's implicit. So the binary code and the hex code. Similarly, अगर आगे बढ़े, so what we are saying कि भाई this is 3 different tasks के लिए किया जाता है. In first instruction, example जो दिए है, both operand registers are specified. Second के अंदर operand B specified, accumulator is assumed. Third के अंदर accumulator is assumed to be the implicit operand, and instructions are stored. And obviously instructions are stored in the 8-bit memory form in memory, and उससे only one memory location is required. तो इसके अंदर जो है ये पूरे ऑपरेशन में only 1 byte of data is required. 8 bits, 1 byte. That is all that is required to store this instruction. वैसे ही अगर 2 बाइट्स को देखा जाए तो 2 बाइट्स के अंदर क्या होता है, ये एज द नेम सजेस्ट, तो उसको स्टोर करने के लिए 2 बाइट्स की जरूरत है. सो फर्स्ट अगेन इट स्पेसिफाइज योर opcode or operation code, and its second one it specifies your operand. तो एग्जाम्पल दिया है MPI A32. obviously सारा डेटा जो है it's always going to be in hex only. So load an 8-bit data right in the accumulator. So it's like from outside जो है accumulator के अंदर we want to load this 32 X data in the accumulator. So MVI A 32. Binary. This is your first byte. This is your opcode है आपका, इसका 3E and ये आपका 32 हो जाएगा. तो अगर MVI A अगर ये FF है तो यहाँ पे you will have 3E and FF. That way it will be. Similarly अगर B को लोड करना है, so here you have the first one is again the opcode. Since this is the here you got your opcode over here, यहाँ पे पहला जो है MVI है. Don't get confused कि भाई ये और ये सेम ही होना चाहिए, क्योंकि ये B के लिए है. That's why ये opcode और ये opcode दोनों अलग हैं. Is somebody saying something? Well, is somebody trying to say something? I don't know. Yeah, should I continue? Okay. Let's continue with our discussion. So, so we were in the 2 byte पे थे हम लोग. So we had said कि भाई अगर दो MVI जैसे operation, so effectively you require 2 bytes to store this kind of an what do we say, this kind of an instruction. And as we are saying 2 bytes are required, data bytes are, here some arbitrary examples they are selecting it. So by MVIC के लिए opcode will be different. But had it been MVI B, say AA, then it would be 06 and AA over here. So depending on your this complete thing, MVI B or MVI C something, that opcode is decided. But certainly we are not deciding. वो already है system के अंदर. वो हम देखेंगे if there is a way to figure out how the opcode is written. That we'll see about. But currently we need to say that भाई हमारे को opcode दिया है and we need to make use of it. That's the way to look at it now. वैसे ही 3 bytes के लिए है 3 byte instruction. So again the first is always their opcode, and then 2 bytes, since now it's a 16-bit, so that 2 is the, so rest of the 2 are the data. So out of the second and third byte, second is the lower address and third is the higher address. So what we now say यहाँ पे जो है, it is taking data from the memory location 2050H. LDA load accumulator with, this is not like this is just specifying the address location of the place from where it has to fetch data. So LDA का है ये 3A, the lower byte is 50, which is over here, 5 and 0, and आपका ये 20 is over here, the higher byte, higher order address, which is, this is 2 and this is 0. That. Then you've got something such as the jump operations, like transfer program to memory location over here. So it's like you jump to this location. So again, jump has this thing C3, and then again 85 and 20. So here 8, 5, 2, 0. Okay, so this gives us some overview of kind of the instruction sets of the UP. So now we got an idea कि भाई तीन kind of instructions है इसमें. One is your single byte, 2 byte, 3 byte. Now let's proceed with the addressing system of this one. So what we are saying is there are numerous ways जिस तरह से आप addressing modes कर सकते हो. So what we saying is that normally हम, as we had said, कि हम mnemonics का use करते हैं, require one or more word to specify the operands. Notations, conventions are used with the operation, but this is actually very less to do. So these are specified by the manufacturer. So, but as far as the MUP is concerned, it is stored in what is stored in binary code. This is the only thing which the MUP is capable of reading and understanding. So the conventions used, they are used in specifying instructions. They are valuable in terms of keeping uniformity in different programs and writing assembler programs अगर बड़े लिखने हैं तो. So again, as we said, that UP neither reads nor understands mnemonics or hexadecimals. These are what do we say, number of ways we can address, but we can try to have a uniformity. पर bottom line यही है कि भाई अगर UP को instruction देना है तो एंड में अगर एक मैन्युफैक्चरर का है या कोई दूसरे मैन्युफैक्चरर का है, जो भी आपका न्यूमोनिक हो, अगर मान लो कि अगर वेरिएशन अगर हो गया कभी, तो एंड में जो है इट शुड ब्रेक डाउन द न्यूमोनिक टू द एग्जैक्ट सेम बाइनरी कॉन्फ़िगरेशन. जो भी इसका जो जैसे हमने देखा, तो इसके कहीं और के अंदर अगर कोई और कोड दे भी दिया उसने 3A के बदले, बट इन द एंड ये वैसे ही बनना चाहिए. And you cannot have this thing 3 like 0011 1110, तो वो ट्रीट नहीं करेगा, वो कुछ अलग ट्रीट कर लेगा उसको. So in the end, what is important is it should have an understanding of the proper binary. एंड में वही सबसे जरूरी है. That's the bottom line of the whole process. Mnemonics जो है, it is for the end user, हमारे लिए है, to make it possible for us to write it. Otherwise, writing in binary would be too cumbersome, too difficult for us. तो अभी ये ऑपकोड के फॉर्मेट्स देखते हैं जो इस्तेमाल हो रहे हैं. तो इसके अंदर जैसे हम देखें तो हर रजिस्टर के लिए कुछ रिप्रेजेंटेशंस है. तो व्हाट वी वर सीइंग दैट काइंड ऑफ पी को ऐसे रिप्रेजेंट करते हैं, सी को वी आर representing it this way. So that would kind of give an impression कि भाई अगर how that we were discussing, ये जो डिस्कस कर रहे थे हम लोग, ये कैसे आया एंड ऑल, तो B को जो है C00 से रिप्रेजेंट कर रहे हैं, दैट इज वाई ये आ रहा है. ऐड के लिए ये यूज हो रहा है because B is being represented by 000. That is why this mnemonic or this hex code of this kind is there. So add C hota, so accordingly यहाँ पे it would have changed to whatever is there for C. वैसे we were over here. So देन इट इज ऑल्सो पॉसिबल, जैसे रजिस्टर पेयर्स की हम बातें करते हैं, अगर पीसी को रिप्रेजेंट करना है एचएल, तो जब जब इंसान प्रोग्राम लिखेगा, दैट टाइम यू विल कम अक्रॉस, it would be useful to use all these things. Some examples which are given, so some of the operation codes are identified. So rotate each bit of the accumulator to the left by one position. Like यहाँ पे example दिया हुआ है, तो इसमें जैसे ये ऑपकोड दिया है आपका, ये 07 का, and add the contents of register to accumulator. So accumulator का ये देखिए, that is what we were saying, that 80 का जो part आ रहा है, so accumulator is kind of being represented over here, and the 3 bits are reserved for the register. जैसे as we were saying that 80 is coming from here, ये use कर रहा है ये, and since it was what we had said, it was B that time, so 000 आ गया था, so that's why it was 80H. and अगर कुछ ये रहेगा तो भाई क्या था उसके पहले, भाई C रहेगा तो 81 आएगा, D रहेगा तो 82 आएगा, accordingly that way your what do we say, your hex code, that way it is formed उसमें. So for example, again example दिया है आपको कि भाई ये add है, ये add के लिए है, for accumulator में register B है, implicit है ये वाला आपका, that is why ये 80H फॉर्म हो रहा है, ये add के लिए है, ये B का है, accordingly अगर C रहता तो ये 001 होता, and you would have had a 81H. ये ऐड के लिए, अगर सब्ट्रैक्ट के लिए होगा तो ऑब्वियसली कुछ अलग आएगा, ये whatever is being used over here, and you would have had a, but again subtract के लिए these 3 parts would be same, since here register B is being involved. तो opcode के लैंग्वेज में, उसकी जुबान में उसको कैसे रिप्रेजेंट करेंगे, add B and 80H is your this one, your आपका कोड है. तो ये जो है सिंगल बाइट ऑपरेशन है ये उसमें. तो दूसरा एग्जांपल जो है वो मूव का है, the contents of the source register RS the source to your destination. तो ये कैसे ये लोग ने ब्रेक किया है. So 0 is kind of the opcode for move any function, and यहाँ पे आपका destination है, यहाँ पे आपका source है. So again example जो दिया है, to move that we said कि भाई ये आपका opcode is for move 01, C का हमने देखा it's 001, A is represented as 111. So भाई कैसे लिखेंगे, from opcode and operand. तो operand के लिए जो destination register है, destination कहाँ है, C में, you want to put it in C, so that is why 01 001 and source is 111. That is how इसको formulate किया है इसके लिए. 4H 4F obviously now, and this is like you break it up, ये 4 हो गया और ये सब ये है तो 15 है तो ये F हो गया. That is why it's 4F hex. So as we said कि भाई it's like 2-byte operation in this case. That's why it's written over here in this way. So कोड का फॉर्मेट अभी देखते हैं। तो यहाँ पे जो है, तो फर्स्ट रजिस्टर इज अगेन एज वी सेड कि भाई ये तो डेस्टिनेशन है। सेकंड इज सोर्स, अभी ये ए टू सी की बातें कर रहा है, which appears to reverse for general pattern from left to right. Typically ये कैसे लिखा जाता है भाई, ये दिखाया है आपको। लाइक ये आपका लाइक सोर्स टू डेस्टिनेशन जाना है आपको इसके अंदर, तो RL is specified as your destination, R2 specified to as your source. That way इसका, so this is the way you have it, your 0 1, और उसके अंदर कोई और होगा तो भी यही रहेगा, like destination and source. Source पीछे रहेगा, destination आगे रहेगा इसके अंदर। So let us just have a look at the basic data formats जो है हमारे पास। One is your ASCII code, ASCII code जो है, this is your 7 alphanumerical code which represents numbers, English alphabets, etc. That's what our ASCII keyboard है हमारा। And 8-bit, yeah, this is your extremely standard way which non-printable characters are also represented. Then दूसरा है आपका BCD, stands for binary coded decimal, and obviously we know it has 0 to 9 है, and so we need 4 bits to represent 10 इसमें, and remaining जो numbers A to F that cannot be represented, they are considered invalid in a BCD codes. तो 8-bit के अंदर जो है आप you can accommodate 2 BCD numbers, since 2 BCDs can easily be accommodated. इसके अंदर आसानी से accommodate हो सकता है, possible है 0 to 9 को accommodate करना इसमें। Then there is a concept of signed integer and unsigned integers उसमें। So signed या either positive number, negative number हो सकता है। So in 8-bit processor, obviously your D7 is the most significant, and 0 represents positive and 1 represents negative sign जब आप signed integer system में जाते हो, and remaining then they are your data bits representing magnitude of an integer. Therefore, the largest positive integer at one time by the 8085 is 7F and not FF. ये जो है वो sign parity के लिए वो छोड़ देता है। The remaining X numbers, they are considered negative numbers. But since all negative numbers are represented in 2's complement इस system के अंदर, तो by default उसके लिए तो ये सारे negative हो जाते हैं, but 2's complement में ये represent करेगा इसको। But by default D7 is there for sign convention, not for data over here. Otherwise, one more way to look at it is the unsigned integers. So an integer without a sign represented by all 8 bits. So the largest number is again FF. This does not imply is limited to handling only 8-bit. Numbers larger than bit, they are processed by dividing them in groups of 8 bits. So अगर number बड़ा है, if it is larger than 8 bits, then it will divide that number into groups of 8 bits each. And then as I said, वो serially काम करेगा, धीरे धीरे slowly हो जाएगा, simultaneous नहीं कर सकता like advanced MUPs, but it will do it in a slightly slower way. So Now let's represent. Let's see how does it interpret any number. So what are we saying? That let us say कि भाई after कोई operation के बाद accumulator में ये number is present. A number of ways you can have the interpretation depending on your application. तो अगर वो unsigned है तो ये 65 हो जाएगा भाई आपका इसके अंदर. एक मिनट, कोई कुछ बोल रहा है? Somebody switched on the camera. Okay. So let's proceed. Continue to proceed with what we were discussing, and then we'll close in some time. Maybe we can close over here. Let's just finish off with what we are discussing over here, and then we can go on over here. So what we are saying कि अगर ये ऐसा number है हमारे पास, or if it is unsigned, then it can be an unsigned number. It can be represented this way. If it's a BCD, then you can have again can be represented again in 41, and it can be the ASCII say capital let A or 4, it's a group of 8. So it is up to the user to interpret the result. So as the bottom line is that number of ways at which you can look at it. आप उसको unsigned number भी देख सकते हो, उसको signed number भी देख सकते हो, BCD के तौर पे भी देख सकते हो. So it all depends on what you have, the way you are feeding it, and the way operation is being done. Same number can be interpreted in different ways. So here an example जो दिया है, तो भाई आप उसको as A भी देख सकते हो भाई, या फिर उसको 41 in BCD भी देख सकते हो. A number of ways you can look at it. So another thing is the memory. So how do we provide information to the processor? So what we are saying is that it's provided by another electronic storage called as memory. Some ways memory is okay. So what we are saying, memory is nothing but 8-bit registers stacked one above the other as shown in the memory model. Fine. So memory, it includes 4 registers, and each register, so 4 registers hai, each register can store 8 bits, and it can be referred to as bytes or 32-bit memory chip, and address lines 2 hai इसके अंदर to identify 4 registers, 8 data lines to store 8 bits, and 3 control signals hai. It's read, write, and chip select. All control signals, they are designed to be active low, indicated by bars. So the processor can select the chip, identify its register, and store. It can read it, it can write it, or access it at a time. And this shows the 4 registers to simplify the explanation. So size is extremely large. Memory address assigned is determined by the interfacing logic used over here. So the simplified model we said, these are the address lines over here. These are the 4 your registers, and along with that यहाँ पे जो है you have control signals है, 3 of them, for reading, writing, and chip select accordingly. So this is like extremely rudimentary way of looking at the memory as far as MUP is concerned. यहाँ पे let us see if necessary we'll go in the details about it. So now let us commence with how to write and assemble and execute a simple program. So where are we? So do you want me to continue? ये topic start होगा तो थोड़ा time लगेगा.
No sir. No sir.
ठीक है. ठीक है. So we'll stop over here where we had a. So before we go over into this one, तो हमने क्या क्या बात की आज, so that we can start tomorrow. Like we discussed the instructions, the one byte, 2 byte, 3 byte instructions. पहले भी हमने कुछ बातें की थी regarding the instruction sets. So today we discussed more on the instruction set of 8085, its various functions, its types, and then some addressing modes, its opcodes, how the opcode is formulated over here, that each one is having certain code, each of these registers, and then you can have register pairs also, like formulation, like opcode formulation, how does it take place, what is the logic behind that. And then we had also different data formats was there, ASCII to BCD to integer and non-unsigned integers. Those things we had just a bird's eye view of that. And then we looked at the data formats, some basic idea of memory. And also earlier also we had discussed few things regarding the architecture and all. So tomorrow we'll be discussing about how to write and assemble the program, and then we might also look at certain instruction sets. What do they mean? What do they imply? And then we'll go on further in some certain more details of writing certain assembly and execution of simple programs. Okay? So any कुछ पूछना है?
So where to refer
No.
notes?
गांवकर से ही मैं पढ़ा रहा हूँ. गांवकर है आप लोग के पास, या फिर गांवकर की सॉफ्ट कॉपी में आप लोग को ये करता हूँ.
Okay sir.
Okay, sir, you can say.
ओके. गांवकर, क्योंकि ये सब कुछ तो गांवकर से ही है. एंड फिर 8085 खत्म हो जाएगा तो फिर विल बी रेफरिंग टू अनदर बुक. बट करेंटली तो ये सब कुछ गांवकर से ही चल रहा है.
सर ये बुक का पीडीएफ है या अलग से पीडीएफ है?
ये बुक का ही पीडीएफ से मैंने लिया है सब कुछ.
ओके ओके.
अरे ठीक है. ये रिकॉर्डिंग नहीं हो रहा है क्या? रिकॉर्डिंग बंद कैसे हो गया? I don't know what happened. Anyway, स्लाइड्स तो शेयर हो जाएगी आप लोग के साथ, एंड बुक भी मैं शेयर कर दूंगा आप लोग से. ओके?
Okay sir. Okay sir. Okay.
Okay, sir.
Okay. See you then. Bye.